Good morning, everybody. Happy World Refrigeration Day and welcome to RAC's Question Time Extra Time on the subject of CO2 refrigeration. We're very grateful to Panasonic for supporting this, and you'll hear from them shortly. We're also joined by some of the leading experts in CO2 refrigeration on our panel. I'm particularly excited to be discussing CO2 as it was the subject of my first conference at RAC way back in 2009, when it was all mostly theory. Now, I'm glad to say it's very much about practical solutions with CO2, as we will hear. And to judge by the record number of people registering here, the potential of CO2 is something that the industry wants to learn more about too. So without further ado, to kick off proceedings, here is Alfredo Armaus from Panasonic.
Thank you, Andrew. Hello, good morning and welcome to this special CO2 question time with RAC magazine. My name is Alfredo Armaus and I'm the Panasonic country manager for UK and Ireland. Panasonic are delighted to be part of this webinar in celebration of World Refrigeration Day, particularly as this session is dedicated to solutions that utilize CO2 and how this may be the future for the industry. The F-gas regulations are driving the industry towards the use of natural refrigerants, and very rightly so. Panasonic is leading the way in this area. We have been bringing these solutions to market in Japan with numerous installations for many years, and it is exciting to be growing the business area in Europe and in the UK. At Panasonic, one of our main aims is to create solutions that help to protect the environment and contribute to society. In fact, at Panasonic, we have set a goal to help to decarbonize society and to reduce greenhouse gas emissions in our business activities and products by 30% by 2030 and reach net zero by 2050. I am very pleased to see that we have a range of passionate CO2 experts on the panel today. I'm sure you will all find the discussions of interest. My colleagues will be sharing more about our history and development of our CO2 product range and our objectives for the future during the webinar, and I hope you'll enjoy it. Thank you very much and have an excellent World Refrigeration Day.
Thank you very much, Alfredos. Now, of course, as we've mentioned, we are sitting here on World Refrigeration Day. I think very timely that certainly in the UK, we've just had one of the hottest days of the year, and now we're celebrating coolest day of the year. Now we're hoping by the power of broadcasting magic that Steve Gill will be joining us shortly, but he's not here yet, so he's clearly on a webinar or meeting some of the world's press, but we'll hear from him later. So let's get straight into the world of CO2 with Mick Langford from Panasonic to give us some context. Mick.
Thank you, Andrew. Good morning, everybody. My name is Mick Langford. I'm a sales manager with Panasonic, and I look after the specified sales team and the direct sales team at AMP. I'm going to share my screen with you and run through an overview of F-gas. If you just bear with me a second, I'll just pull that up. So hopefully, I think everybody can see that now. So F-gas regulations, I think it's fair to say that the vast majority of people attending the seminar today are probably very aware of F-gas. So this is really just a helicopter view of F-gas regulations, and in particular pointing out how it can lead us towards the use of CO2 and perhaps why CO2 is a natural avenue to go down in terms of refrigeration requirements as we go forward. So to kick things off, what are F-gases? Well, I think we all know that they're chemical gases which contain fluorine, and HFCs as they stand are the most common F-gases that we use in the bulk of the systems that we all sell and install and service and maintain in the industry. So in refrigeration and air conditioning predominantly. And when we talk about refrigeration systems, there's many HFCs, as we know, but the most common ones we use in refrigeration circles are 404A, 134A, and R507. So if we look at the pros and cons of F-gases and we look at the scales there, we can see that we have a number of positives for the use of F-gases, which we're all well aware of. But on the opposite side of the scales, we have some pretty difficult challenges to overcome. So we all know that F-gases have high global warming potential. The phase down of HFCs has resulted in prices, astronomical prices, I think, in many respects on those. And there's also many special limitations, particularly on A2L gases. So that tends to put us in a situation where the costs are increasing all the time, and we need to consider that when we're selecting systems for our customers and clients going forward. So when we talk about the high global warming potential of HFCs, so what's GWP? Well, I think again we know it's how much heat. It's a measure that specifies how much heat is trapped in the atmosphere by a HFC refrigerant, and how that compares to natural CO2. And if we look at CO2, which has a GWP of 1, we can see that the commonly used refrigeration gases have very high GWPs by comparison. And as a consequence, they contribute quite hugely towards global warming. And they justifiably have the title of greenhouse gases, I think, as a result of that. So F-gas regulations, it's an EU regulation that first came in 2006, was amended in 2014 with 517, and has been applicable since 1st of January. Now, the main goals, which center around the F-gas regulations, focused on reduction of emissions of F-gases, limiting the amount, particularly of the highest and highest GWP gases, and then going forward, the banning of the use of F-gases as time moves on. So if we look at preventing emissions of F-gases, very simply, we're talking about replacing high GWP refrigerants with much lower ones, and obviously designing our systems to reduce leakages, more maintenance, more servicing, checking of systems to make sure that they're okay. Additionally, we're talking about the quota allocation, which is reducing, which I'll talk about in a second. It's the common phrase we all know, which is phase down. And again, as I mentioned a moment ago there, ensuring low leakage design on systems as well, particularly important. So if we talk about phase down, we started back in 2015 with 100% usage of all the common HFCs that we used. And sitting where we are now in 2020, we're running up towards a reduction where we're using 45% of that amount now. So a 55% reduction since 2015, and with an ultimate target of reducing to 21% by 2030. But I think it's fair to say that the industry has always strived to improve on these things, and it's quite possible that we'll see that 2030 target being achieved earlier, quite possibly, I think. So again, on the F-gas regulations regarding goals and the banning of the use of F-gases, we have new HFC bans contained in the regulations, and we have to consider which refrigerants to use on the low GWP side as well. And one of the key things there as well is obviously reducing the amount of refrigerant in systems, and they're things that have been moving forward and happening in the industry as the years have gone by. So the HFC ban, which has come into play from the 1st of January, so that's already upon us, relates to 404A and 507A. and so that's having an impact here and now. But by the 1st of January, we're going to find that HFCs with a GWP lower than 150, which includes 134A, are also going to be outlawed as well. So what are the consequences of both phase down and HFC bans? Well, I think it's fair to say that we would agree that whilst there's no major, if you like, comment or detail in the F-gas regulations pertaining to CO2, it's a powerful driving force towards using CO2 as a refrigerant of choice in refrigeration systems in the market today. And bearing that in mind, we still have, we have to think carefully, as we said a moment ago, about CO2 as it stands, and the fact that it gives us a way forward, and a positive way forward for customers, some surety around the systems they're investing in, and helping them to have confidence that they have reliable systems, that they're not going to be subject to astronomical charges on refrigerants and things if they're phased out. So I'm not going to read all these out, but with CO2, I think we all know that there's many, many benefits now. Andrew touched on the fact a moment ago there that he did his first CO2 discussion many years ago, I think it was 2008, I think he said. I think the thing with that is now the technology's moved on dramatically, and as it always does in our industry, and we've always been very positive about introducing new things, such as, and Panasonic have been at the forefront of that, particularly where CO2 is concerned. So it really is a very viable option for the future going forward. And just to finish off, really, I think we all know that we've now left the EU. So the F-gas regulations was primarily driven a piece of legislation out of the EU Commission. But I think we all know as well that the industry has, or the government in the country has transposed all EU law into UK law. So that's already happened. And so the likelihood of any of this being rolled back or eased up on, I think, is incredibly unlikely. You only have to look at the government's position on pollution, be that with cars, be that with energy production, to see that there's a big drive across all parts of industry to improve our environment. So these things are here to stay, and I would say they're very beneficial for our environment, and will improve it for everybody and in the future. So that's pretty much what I've got to say. That's my overview finished. I'll hand you back to Andrew, who will introduce the next of my colleagues to take things forward. And thank you very much for listening and taking the time to join on World Refrigeration Day. Thank you very much.
Well, thank you, Mick. In a change to the published agenda, we are now joined by Steve Gill from World Refrigeration Day. So we're going to slot him in to allow him to go off and meet the world's press, ambassadors, etc. Done that joke once, sorry. And then we'll pass on to Joma afterwards. But delighted that the founder of World Refrigeration Day, RAC Gold Award winner, has joined us just to talk a little bit about, I guess, World Refrigeration Day and how sustainable cooling fits in with that. Steve, welcome.
Thank you, Andrew. I'm sorry to gate crash your party. It looks as though you're all having so much fun. I heard the end of it, but end of the last speaker. Looks so exciting. Yeah, no, really, really thrilled to be joining you. Yeah, what can I say? World Refrigeration Day. Well, yeah, the coolest day of the year. Doesn't feel like it at the moment, though. It feels like the longest day. I know I've said that many times, but it really does. I saw it kick off in New Zealand. Was it 10 o'clock last night? It was amazing.
I guess you expect me to interview you now, eh? I guess
I was expecting an interview session. No, whatever you want. Yeah, I've just popped in to say hello and excited.
Okay,
to see you
brilliant.
going on.
Well, just give us 30 seconds on what you think the day is going to bring, and then you can give us 30 seconds on how CO2 refrigeration could fit into all that.
Okay, what the day could bring and what I hope it will bring is raising awareness of the great work that we do. I mean, we talked about the theme this year is the cold chain, as you're well aware, and most people associate the cold chain with food supply, because we relate that to our kitchen and our refrigerator, but it's much more than that, as you're well aware. I mean, I know I'm talking to the educator here, the well-informed. Pharmaceutical, medical supplies, all the rest of it. And it works continuously, hidden behind the scenes, and it works so well because of the people that keep it running. And we're the hidden industry, and what I'm hoping is that we'll lift the lid a little bit on these people that are keeping the links together and keeping the wheels running of the industry. And in terms of, to answer your second question, I think it was a question, in terms of sustainability, yeah, refrigeration, sustainability, cooling, it all has to go in hand as everything is warming up and as the need for cooling increases. It cannot continue as business as usual. We do need to continue supplying cooling. We cannot live without it, but to supply it without taking measures to do it sustainably and with various measures, including CO2 as refrigerant, energy efficiency, better technology, we can go nowhere. So I'm hoping that will not piggyback, but be part of the message that's coming out for World Refrigeration Day.
Great, and there are a lot of activities going on. And we've agreed that there's more attempts at getting policymakers and governments to listen this year. So that's quite a focus, isn't it?
Yeah, it is a focus. I mean, it's not going to happen overnight. But they are now starting to take, listen, there are more, I mean, last year was a step in the dark. There are now people taking attention. I've just heard that hopefully a minister will be making a speech on the 3rd of July. I hope I'm not going to, this is going to kill this now, isn't it? I shouldn't have said that. I'm hoping that very soon we'll be get mentioned at the British government in an official speech, but it's other governments around the world are embracing it. I've just come off a webinar with UNIDO, and various governments there are very much taking and embracing it, because it fits in with economics, it fits in with their policy, it's sustainable, and it fits in with their plans for the future. So yeah, it's a great opportunity to bring our message, the right message, because there's lots of messages around cooling, to the to governments and policymakers, and they are listening and taking it on board.
Okay, then, before we let you go, there's one little fun thing that we're all trying to achieve for World Refrigeration Day. So do you want to explain that, how we get the mosaic of Lord?
Oh, the mosaic. I wasn't sure if it's a mosaic or collage, but when I think of collage, I think of sticking bits of pasta on it. From my school days, string and pasta and glue. So I've called it a mosaic. Yes, if anybody, everybody on this, if they're on LinkedIn, if they could find the LinkedIn post for World Refrigeration Day, what we're trying to create is a mosaic of people's faces for to show how many, just to show that we're not that hidden industry. Unfortunately, the software I'm using, we need 500 as a minimum. We can have as many as possible. I think we can have up to 10,000, but the software is calling for 500. We're currently at around, I think 300 last time I looked, or something like that. So still a long way to go, but if we can get another 200 by close today, I'll produce that mosaic and we can show the world with pride.
So you can repost that. Are you going to repost that to because you've been posting quite a lot. I was just thinking you could post it again to the top of LinkedIn. And
it's pinned to the top of LinkedIn.
Okay, brilliant.
It is pinned and to the top of Twitter. And if I ever get around to doing Facebook, I'm not having a lot of time today, but yes.
So for all those technophobes, you actually have to like the LinkedIn post and you have to put a comment on the bottom, don't you?
Yeah, officially you don't have to like it. It would say that it would be shared around rather than asking people to share. But if you leave them, it's just so that I have permission to use it. If you leave hashtag 2020 HVACR faces, I will take that as go to add it to the mosaic.
Brilliant. Well, good luck with the rest of the day and listening to some of the the event
Yeah,
if you
if
can.
you're okay, I'm gonna hang around for a few minutes and
Hang
listen to some
around,
more.
brilliant.
Yeah.
Well, we're going to crack on. So you can now, you have official permission to mute and remove your video. And thank you very much for your time.
Thank you.
Seamlessly, I'm going to hand over to Joe Makasanovas from Panasonic, who's going to tell us a little bit about what they've been doing. And then after that, we will throw forward to our panel of experts. So, Joma, over to you.
Hello, everybody. Good morning. My name is Joma Casanovas. I'm working in Panasonic in the headquarters. I'm based in Germany, where the headquarters is based. And basically, I'm in charge of the condensing units for CO2, for refrigeration business. So let me share today's presentation. Just a moment. So I hope everybody can see the presentation. Okay, so first of all, okay, so as today is, we are in the Cold Refrigeration Day, so I'm sure that everybody knows Panasonic, but let's jump directly to the Panasonic refrigeration business. Just to show that we are not, let's say, a new player in the refrigeration market. Probably everybody knows about air conditioning and these kind of things, but in Europe, we are quite new. We are starting this business, but not in the world. With this map, let's say, we can see the factories, where we have factories. For example, let me, put this pointer. We have factories in Japan. We have factories also in Asia and in China. And currently, we are developing the refrigeration business in Europe. But as you can see, we are not only providing in the Japanese market, we are not providing only the condensing units like in Europe. We are providing also showcase, we are providing standalone units, we are providing vending machines, also compressor racks, and a lot of product, let's say, related with the refrigeration market. So also since some years ago, 4 years ago, we acquired Hassmann. Hassmann is a big company, 100% involved in refrigeration, as everybody knows. And so now we are developing the business also in USA and in Oceania together with Hassmann, which is inside the Panasonic group. To say, to show a bit the business in numbers, we can say that we have more than 50 years of experience just only in refrigeration, in commercial refrigeration. So again, to say that we are not a new player. We have around 20 years manufacturing CO2 compressors. Currently, we have launched to the market around 1.2 million of compressors of CO2. We are talking only about CO2. Remember that our compressors factory is the biggest or the large factory in the world of compressors. Then we have also 10 years of experience just in condensing units for CO2. Of course, we are also in the past producing condensing units with some other refrigerant, with HFCs. But currently, of course, we are producing condensing units since 10 years ago, just for CO2. This was really a big exit in Japan. We already sold more than 12,000 units in Japan. This technology is exactly the same that we are bringing to Europe, and that the one we are referring to the market currently. And in Europe, already sold around now, maybe around 700 units, near 700 units. So just to say that if you look into this map with this big experience in refrigeration, in CO2 also, and the big amount of condensing units already sold in CO2, so everything, let's think that we have a high reliability. That's completely true. This is a very safety product and it's completely well tested, let's say, since years ago. Okay, so next, sorry, oops. Next slide, just to show a bit the expertise of Panasonic in Japan inside this business. As you can see, we have several customers aligned, let's say, in the cold chain category. So one of them in the category of the supermarkets is the Carrefour, you already know. Also in the restaurants, McDonald's. In logistics, of course, we also have customers, and in the beverage sector, for example, Coca-Cola. To say that in this cold chain, we are providing a lot of product, as you can see here. But to say also that we are in sales, we are #1 in Japan. We are also #1 in China, #1 in Asia, in Oceania, and in North America. So, of course, we want to be also #1 in Europe. So we need to wait a couple of years probably, but this is our intention, of course. So, next, let's, after this quick introduction about the refrigeration business from Panasonic, now I will show you this quick diagram. This is our concept of a transcritical system for CO2. We are working with a double-stage rotary compressor, probably everybody knows. Then we have the intercooler. The intercooler is placed this way. This is to reduce the temperature of the first stage of the compressor. Then we have the split cycle. This is a pattern, later we will talk about this. And then we have a sophisticated oil return method and strategies to return the oil to the compressor. And also we have a heat recovery system, okay? So now let's see a bit more in detail the compressor. This compressor, as explained, is a double stage compressor. If you look in this diagram, looks like two compressors. This is just to show the two stage, but in fact, this is one single compressor. This is not a booster system, completely different. This is just one compressor. As you can see, we take the suction, the gas from the suction line, then we discharge the first stage into the intercooler. The intercooler is placed between the two stages, okay? And then we back again to the second stage, and then this is the discharge of gas. If we take this example in a single compressor stage, for example, what we can see is a big or a large difference of pressure. Then the compression ratio is super big. But the strategy to use the double stage compressor together with the intercooler bring this solution. So this means that this is the first stage, this is the intercooler, and this is the second stage. The difference that what we can see easily is the difference in temperature. For example, we can see here in a single stage compressor, we can arrive easily to 120, 150 degrees in the gas discharge of the compressor. But using the double stage compressor with intercooler, as you can see, we raise the temperature of the discharge gas around 80 degrees, which is a half of a one single stage compressor. The benefits working in this way are different ones. One is we are reducing the compression ratio between the stage, so the compressor is suffering less stress inside. This means that we are losing, we have less leakage inside the compressor, because in this way, the leakage inside the compressor is affecting to the efficiency with the big pressure. But second, reducing this temperature in the discharge gas, we're helping the oil to be in the best to keep the better features, to keep always the best conditions, the working conditions. So we are cooling, let's say, anyway, in a first step. Then you will see that we are cooling 2 times, but in this first step, we are helping the oil also to be cooled. So everything, these factors are helping to be more efficient. Also, of course, if we are working with less temperature, the reliability of the compressor, because the oil is in best conditions, is also enlarged, let's say. Another factor is the mechanical point of view. As we have 2 stages, in this case, working at 180 degrees separately. So this is providing a very nice stability from the mechanical point of view. So we have less vibrations and less noise, but mainly the less vibration is bringing more reliability also for the compressor and the whole system. So now let's see another important component inside our technology, which is the split cycle. This is also a patent. First, to say that the compressor, the 2-stage compressor, is a patent from Panasonic. Then a part of the compressor, which is a patent, we also patent the team, let's say, this team, which is the compressor working with the split cycle. This split cycle is an economizer, is a mechanical subcooling, let's say. But thanks to this patent, also, we can achieve bigger efficiency. Basically, you have here the scheme, the diagram. You have here the first stage, the intercooler, where we are cooling, let's say, the first stage of the compressor. Then we have the second stage compressor, gas cooler, and then we have this split cycle. This split cycle basically is a subcooling system, okay? So basically we can reduce the temperature of the liquid line even close 0 degrees. So we can achieve a big efficiency in the system. Some other competitors, let's say, they can use this compressor because this is available. This is a compressor which is available in the market, but they are not allowed to use this kind of mechanical subcooling. So become something like that. So it's just to see that this is a clear advantage in terms of efficiency and capacity. Now, let's talk about the oil. This is a very important point. We have a very sophisticated oil control. We estimate that only the 3% is, let's say, traveling by the pipes and the evaporators. This is an average, 3%. But we are quite confident that this is normally the amount of oil that we will have inside the circuit at any condition, thanks to the strategies that we are using. So then, talking about the oil, of course, the first stage, as I already explained, is first, in the first stage is a bit cooled by this intercooler, then back to the second stage of the compressor. And then the second stage is going directly to the oil separator. This oil separator, of course, is keeping the oil in the bottom part of this receiver. And then this oil is collected and back to the compressor. But first of all, we have this oil cooler heat exchanger. So this is a second cooler, let's say, for the oil. So again, let's say that we are cooling the oil to keep the best conditions inside the compressor, where the oil must be. Then a part of that, we have also, let's say, our oil level control, this point. This is also developed by Panasonic, especially for this compressor. It's own technology, let's say. And finally, let's talk about the oil. This is a pack oil, which we consider, which is the best oil for CO2 transcritical applications. But this is not, in fact, a standard oil. Some competitors are using the standard oils available in the market. But this oil, in fact, is designed based on experience. As we explained, we have 10 years of experience producing CO2 condensing units. This is super important because this product is placed in Europe, getting the same experience from Japan and the same technology. So this means that this oil was designed with additional additives on this oil. And then this allow this oil to be super, let's say a super oil, say in some way. And this is allowed to support high levels of humidity. Also, thanks to this strategy, we can keep this oil colder than in standard systems. And then thanks to this, we can lubricate completely the compressor. And this 3% of the oil that is moving by distillation can be recovered easily because this is always in the best conditions. Okay. So now let's move to the heat recovery, just to say that we already have some units with a heat recovery port. And this become a good, very nice, good feature for CO2. Our 10 horsepower unit is able to produce even 20 kilowatts, to recover even 20 kilowatts for hot water producing, let's say, for any application, okay? This is our lineup. In this lineup, this is the current lineup. Just only these two models, these 4 horsepower models, will be launched this year. So for this year, we have planned to launch these 5 models. The first one is the 2 horsepower unit. This unit can be used for medium temperature or for low temperature, up to minus 45 degrees. Then we will launch this year these 2 models with heat recovery connection also. This one for medium temperature and 1 for horsepower also for low temperature applications. And then we already have these 2 models, which is 10 horsepower units, which is honestly unique in the market. Talking about the cooling capacity, we have in this kind of cooling capacity, there are not any other products. And then we have one model with just only medium temperature, or another model which can provide medium temperature or low temperature, and also heat recovery. Okay, now just let me show some examples, sorry. Let me show some examples with the 2 horsepower unit. This in UK, this is the NHS hospital in UK. This is installed in a working freezer working at minus 50 degrees. This is another installation working in low temperature in Belgium. In this case, as at this moment, we cannot provide the 4 horsepower unit that will be provided soon. So we installed 2 condensing units working at the same time into the same cold room. And basically we link the defrost system just to provide the defrost at the same time. Eh? And then this is a clever idea. This is provided also for the green cool. This is a mobile rental truck where you can bring your cold room whatever you want. As you can see, this is a clever idea. This is the condensing unit. It's installed here. And thanks to the ability of this condensing unit to work, to can change the evaporation temperature just with a very easy way with a rotative switch, we can select not only the evaporation temperature, but in the same switch, the same rotary switch. At the same time, we select all the parameters of the condensing unit for different evaporation temperatures. So it's super easy to select any evaporation temperature. So you can bring the cold room with for medium temperature or low temperature at any place. And then to show this interesting point, this we are feeling a grow in, let's say, we are feeling that this kind of supermarkets. You can see this is a bio supermarket. This is 2 different supermarkets. are following the trend of the let's say to be green, no? So this is why they are preferring to install natural refrigerants. Even we are seeing that in the showcase, they are placing some kind of stickers or even in the entrance of the supermarket, just to show to the end user that they are aligned, let's say, with the green concept, and the refrigeration system is working with natural refrigerants. So this is a very marketing point of view, but it's interesting to see like a trend in us, you know. So then finally, just to say that all our product is produced in Japan. We have an excellent quality control. Believe me, that's super excellent. The team working in CO2 in the production line is a super skilled team. Only the best team is allowed to work in this production line to the complexity of the excellent quality control. And then just to remember that we have more than 50 years of experience in refrigeration. We are not new. So we have more than 10 years working in condensing units for CO2, exclusively for CO2, and more than 13,000 units sold between Japan or Asia and Europe. And that's all. Thank you very much. I think see you later in the next panel.
Thank you very much, Soma. If you just want to stop sharing your screen, great.
Yes.
Brilliant. So we'll move on to the panel now, where we hopefully will be exploring a little bit more of the benefits of CO2 and a little bit of a wider context. When we talked about setting up a panel of experts, there were 2 or 3 people on my list, and I'm very pleased to say that top 2 are represented today. Chris Vallis, a consultant, and John Skelton, arguably pioneer of CO2 refrigeration in the UK. So I think we're going to Chris first to hear a little bit about the wider context. Chris.
Hi everybody, thanks Andrew, and yeah, thanks to RAC for hosting this important event and for inviting me along. I'm Chris Vallis, a founder at Livingston Consulting. We're a consultancy working in the built environment in the UK and in North America, and our team have a specialism in refrigeration. So just some background from me, no slides, but more of a broader view around the challenges generally. I was lucky enough to be part of the design team for the first CO2 supermarket in the UK back in 2005, a system conceived by Nick Rivers, who I'm sure most of you know. And we were lucky enough to then work under John Skelton as a consultant supporting Sainsbury's over the subsequent decade, when John did some hard yards to make it business as usual. And yeah, be a leading light in pioneering that technology in the UK. And today, Sainsbury's have got more CO2 systems than the entire United States. And our new head of US operations was also a strong advocate and an early adopter of CO2 during his tenure at Whole Foods in California, Tristan Coffin. And California is a state leading the way in setting new regulations, now actually becoming slightly stricter than the FCAS regulations. From a human perspective, for me, I think having children in the last few years has really sharpened my focus to what I feel to be increasingly important: the existential climate crisis and the dramatic action we need to take. To the extent where I feel there's little debate in this subject matter of refrigerant choices. One thing I read recently around the climate crisis, which has really stuck in my mind, is we need to sound the alarm, but we also need to show where the exits are. So we redefined our mission as a consultancy last year to pioneer sustainable change in the built environment, and rebranded accordingly. 2 guiding insights that helped us define that mission were the Bill Gates annual letter last year, which talked in detail about the climate crisis and population growth. Population growth is set to hit 10 billion by 2050, 7.5 billion today. And the global building stock is set to double by 2060, so in a similar time frame. And that growth in building stock is equivalent to a new New York City every month for 40 years. So with that phenomenal growth in the built environment, we have to change the way we do things, to echo what Steve was saying earlier. Another significant guiding principle for us was Project Drawdown, which again I'm sure most of you are aware of, and if you're not, I implore you to read that, so drawdown.org. That's a global research initiative that's been assessing relative magnitudes of different strategies to mitigate global warming. Refrigerant management and alternative refrigerants, or natural refrigerants and CO2 combined, is projected to eliminate 100 gigatons. So that makes it about number 3 or 4 on the list of all climate change mitigation approaches in comparison to food waste, wind turbines, family planning, you name it. And that figure is about twice the greenhouse gas emissions of all nations in 2018. And for the avoidance of doubt, that simply represents the potential global leakage of chemical refrigerants. So all of this has made us really focus on, realise and appreciate that we're privileged to work in a field that can have such a significant positive impact on this existential climate crisis. Those figures I mentioned about 100 gigatons, estimates actually stretch to 450 gigatons if you include air conditioning and energy efficient systems, and those things are factored in. So this is a huge opportunity we have in our grasp. And I think the solutions to climate change exist, and we need to use them more proactively. Hence this type of conversation today, which I welcome hugely. I mean, obviously we're in a very strange time globally. And I think there's already talk that post-pandemic, we need to now talk of a green recovery from this coronavirus crisis. Rethinking investment in infrastructure, supporting low carbon industries. And as a designer by trade, I think simplicity is always of paramount importance. And the argument for natural refrigerants like CO2 is quite simple. So naturals don't deplete the ozone layer. They make a negligible or zero contribution to global warming, and they are sustainable and energy efficient solutions, and if adopted now, they're future proof. So I think my closing message would be that we need to pay attention to what science tells us about the threats from nature, and we must use our energies combined and a renewed focus and an appreciation of global well-being, and embrace the similar yet potential and far graver climate warnings, and be unflinchingly bold, decisive and purposeful, and collectively shape a world we can all thrive in. So like I say, that's all I really wanted to say, and I think I don't want it to be that I'm on my soapbox, but I think that, you know, it's fair for me to give my context, and I think I'm happy to take any questions towards the end. But thank you for everyone's time and inviting me along.
Thank you very much, Chris. Very interesting bit of wider context. We asked you for the bigger picture. You gave us the bigger picture. So at this point, I should actually mention, because I'm not sure everybody's cottoned onto it, there's a Q&A box at the bottom of your screens. And so if you wish to ask the panel a question, then do please use that facility. I'm going to move on to introducing John, and then we will bring back the panelists for a few specific questions, because this is question time. But without further ado, John Skelton.
Good morning, my name is John Skelton, and I'm currently the refrigeration manager at Marks and Spencer's, and I'd like to thank Andrew and Panasonic for inviting me to be a panelist today. Great introduction. Hopefully you won't be underwhelmed with what I've got to say, but got a bit of experience with CO2 which I thought I'd share. So for those of you that don't know me, until recently I was head of engineering at Sainsbury's, and I left to join Marks and Spencer's 6 months ago. I started my career as a refrigeration apprentice in 1984, working for a retailer, and I've been working for a retailer ever since. So as a shopkeeper, I'm not sure I'm really qualified to talk to you about CO2 refrigeration, but what I can share with you is my experience of rolling out CO2 in what now must be around 200 stores and counting, and my view on natural refrigerants going forward. So why am I such a fan of natural refrigerants? Well, it probably, in some ways, dates back to September 1987 with the agreement of the Montreal Protocol. I obviously didn't understand how things would pan out at that point. But then it was the point that I had to start having uncomfortable conversations with my employers. Uncomfortable conversations about having to spend significant amounts of money that wouldn't generate additional sales. Yes, the money would ensure that we were legally compliant, and it was definitely the right thing to do from an environmental perspective, but still a really tough sell to a retailer. And it didn't stop there. That was just the start of it. The uncomfortable conversations continued. They started with CO2, but they soon moved to HCFCs, and now we're phasing out high GWP HFCs. These were all conversations about spending money that wouldn't drive sales on chemicals with names that all sounded very similar. I've been asked on more than one occasion in a boardroom whether the Montreal Protocol and what's followed was some sort of conspiracy by the refrigeration industry to generate work. So when did my journey with CO2 start? Well, it was about 12 years ago when I was faced with the challenge of moving away from HCFCs and in particular R22, and I took the opportunity to persuade the business to make the step change to natural refrigerants and avoid a move at the time to a high GWP HFC. I was convinced it was the right thing to do, as although there were going to be challenges, CO2 is likely a future-proof refrigerant, and selfishly, I should be able to avoid uncomfortable conversations in the future, asking for money to move to yet another refrigerant. So I was convinced the move to natural refrigerants was the right thing to do, but why did I pin my colours to transcritical CO2? Well, the credit really goes to my supply base at the time. They convinced me it was the right thing to do. I just had to make a huge leap of faith, as it was going to be a career-defining moment. What helped was that all of the proposals that were presented to me had been tried and tested by other retailers across Europe, and many of the components and pieces of equipment would be familiar to the engineers that were currently maintaining our HCFC and HFC DX systems. Change is always difficult, but I felt the transition would be smoother if the new plant looked and felt familiar to our existing systems and our engineers. My first priority was health and safety, so I helped develop the BRA CO2 short course, and I spent a considerable amount of money training engineers to help them work safely on CO2 systems. I did the BRA short course myself, and I have to admit, I was scared of it the first time I carried out a few simple service-related tasks. But I soon obviously realised that if you work safely, there's nothing really to be scared of. It was funny though, the group I was in, we all took a huge step back when the gauges were first removed from a CO2 bottle. And we all felt a little bit embarrassed when we were underwhelmed by the little hiss that came out of the lines as they vented. That said, you'll still see me jump if I'm standing next to a discharge line when the PRV vents. We've gone from having engineers hiding in their vans rather than facing a CO2 fault. And a lot of the engineers that I speak to now seem to prefer to work on CO2 systems. Not too sure whether that's just because they're a bit newer, but certainly the confidence is out there. Was the transition to CO2 simple? No, it wasn't, and I have scars to prove it. But it's happened. There are thousands of CO2 retail refrigeration systems out there now, and it happened because of our amazing industry. It only took a nudge to get things going, and then our industry stepped up and made it happen. I never had any doubts it would. I've worked with some amazing people over the last 36 years that have always risen to the challenge, especially around the environment. Component selection back in 99-2000 was a challenge, and we learnt very quickly about the component choices that did and didn't work. We rolled CO2 out at pace, and we spent a lot of time refining the plant design from our learnings and returning to sites to swap out unsuitable components. The good news is we are all now benefiting from the learnings from those early sites, and the CO2 plant and components today are far more reliable and readily available. What I was worried about back in 2000 was the simple things like getting hold of CO2. I felt from day dot that it would be a problem, but nobody seemed to listen. So we went through the pain of having to turn away refrigerant tankers because we couldn't accommodate them. We had problems with 24-hour helplines that weren't 24 hours, and there was a shortage of vehicles and CO2 bottles to transport the refrigerant. I remember sitting in a coffee shop in Paddington trying to convince one of the major chemical companies that I was serious about a move to CO2 and they needed to invest in their infrastructure. I'm happy to report that the pain we all went through back then means we're rolling out reliable and cost-effective CO2 solutions now, and the future of CO2 is looking very bright. That said, there are still going to be challenges around energy. In my experience, the profile is better than expected, but energy is also always going to be a concern for refrigeration systems. There's also more to be done around total building solutions, whether that be better use of waste heat or designing buildings where the different discipline solutions work more harmoniously together. I'm also pleased to report that my predecessors at M&S had similar views to mine, so I'm continuing to roll out transcritical CO2 solutions. I personally feel natural refrigerants are a bit of a no-brainer. I totally understand that there are challenges, but not only do I think it's the right thing to do for the planet, but there are fewer reasons and applications than ever where a natural refrigerant isn't a viable solution. I'm excited to see how natural refrigerants develop in the future with advancements in technology and thinking, and I'm also keen to keep an eye on other solutions that are coming over the horizon. I'll now hand you back to Andrew.
Brilliant. Thank you very much, John. So a little bit of housekeeping. We're not doing hand raising today, so could you submit your questions, please? Equally, to my fellow panelists, can you not answer questions on the text, because the idea is that we ask them to everybody. Well, we call it question time. So they're coming through me. As quite often happens, so the folk who've spoken already, if you want to put your videos on, and we can do it like that, and I can see you and ask you questions as they come on. We'll go straight back to John, because a couple of questions have come in, which is around skills and training. You mentioned that. What's your view on what we need to do now to raise the bar for skills? Because it's pretty clear that we need more trained contractors.
Yeah, I think training is a wider issue than just working with naturals or CO2 for our industry. We've got an ageing demographic. We're struggling to get the right people to come into the industry. There's definitely going to be we're definitely heading for a problem in the future if we don't address that. There's going to be a lot of great people that could be leaving the industry soon because they're going to be retiring. The IOR is taking some leadership in that area, so they've helped the employers push forward the Trailblazer scheme, which is going to help address quite a few of the training shortfalls that are out there at the moment. But it's about companies realising the importance of being able to develop their individuals, help those individuals with their career path, and again attracting the right calibre of individual into industry going forward. There's some good stuff out there. The thing I've really learnt around CO2, which is that being very nervous of it at the start, if you've got a good refrigeration background and a good understanding of refrigeration, the step to CO2 isn't that significant. But again, it needs to be treated seriously. Yeah, I'm pleased to say I think things are improving, but there's a lot of work still to be done.
Thanks. A follow-up question to that is, and again, Chris, you could answer this, or John, would you like to see it mandated? There's an F-gas review coming up, so tie it into the whole F-gas picture. Made compulsory to train on alternative refrigerants.
Well, let Chris answer that as well. But my view is that we need more suitably skilled engineers in our industry, and that means that they're suitable training for the tasks they are carrying out. So would it be right to have a blanket qualification for anyone who touches refrigerant? I think that's something that maybe we need to consider, but is that practical? As an end user, got to say that we're always trying to get the best value for the work we're doing. But it's all about, for me, it's two things really. It's one, making sure that individuals are safe and return home every night after a hard day's work. And it's also giving individuals the opportunity to grow and better themselves. I think we need to have a total rethink on training in our industry, because I think personally it's lacking at the moment. It would be great to see some mandatory training in appropriate areas.
Okay, thanks, Chris. You got a view on that?
Yeah, I agree with everything John's just said. I think I'd maybe just add from a different angle is, I mean, most businesses will have a business continuity plan, and I think really, if any forward-thinking business, again, it wouldn't be a question. People need to embrace these new technologies to be successful in the future themselves. So I think it's an interesting one, making it mandatory. I think I couldn't see that happening, if I'm honest, but I think to me it is mandatory if you want to be a successful business in this marketplace.
Okay. Then handily we can throw over to Joma, which is a specific question about skills. Questioner has said that the rotary compressors is definitely a way forward, but they're not very well understood by engineers out there at the moment. So is Panasonic planning some means of upskilling? Joma.
Yes, of course. I think we are starting to provide some trainings in not only in UK, but around Europe. Since, as you know, since 3 years ago, we are starting to move this forward, this business. But honestly, I think this year is when we are starting in a more serious way, and when we are starting to provide serious training. I think my colleague Indy, who is here today in the panelist, is providing in UK several trainings and also explaining our compressor, our rotary compressor technology. But honestly, I think this is, let's say, a completely new technology. These compressors are working in the market since more than 10 years ago with condensing units. So there are a lot of available information. So yes, of course, we are explaining, we're training people, and if a part of that somebody or someone are interested in some more information, we can provide some further information for them, no problem.
Okay, great, thanks. Here's another interesting question for you, panel. It's come from someone clearly with a broad sweep of history. Over the last 18 years, many different types of CO2 systems have been tried. In that time, we've learned a lot about CO2. Is there a perfect system, an ideal system? Is there a perfect system? And then there's a second part to that, which is reliability is very important. Which systems have stood the test of time? I reckon you're going to have to answer that one, John.
Okay,
is it transcritical all the way? I guess is the very quick summary of that, isn't it?
I think for me at the moment, although I've always felt that CO2 transcritical, they are part of the solution out there. They're not necessarily they're not necessarily always going to be the right solution for everybody, and I'm sure there will be other solutions that will come to the fore in the future. The one thing that I've really liked about the CO2 transcritical is, as I've touched on, it's a system that looks very similar to the DX systems, HFC systems that the engineers were previously working on. So it's made the transition across to CO2, I believe, simpler for engineers. From a reliability point of view, the reliability of the components and the equipment that's now being specified, it was pretty good in the first place, but it's far superior now. So we are in a better place. Is it giving us the right availability from a retailer perspective. I think there's definitely things we need to do to improve the reliability of the equipment. So we've still got that as a challenge going forward. But at the moment, that flavour seems to be the one that's working, seems to be one that engineers are comfortable with. And that's the real big thing for me is making sure we've got, again, the real driver is from a health and safety point of view, but I've got to be, got to be honest, I'm from a selfish perspective, the better quality engineers that we have, the more confident they are with the equipment that we're installing, hopefully the quicker they're going to be able to fix it. So there's going to be a benefit there. And as Chris said, all the companies I talk to, when I talk to them privately, say they know that if they have the right engineers with the right skills, it will make them more profitable businesses. So yeah, I think transcritical CO2 works really well in the retail environment. Probably a flavour that we'll keep with for a while.
And just as a follow-up to that is, which you may well have answered, I think, in the last answer, have you abandoned Cascade because of the energy? It's not you, it's you in plural, because of the energy numbers, or?
It's I suppose at the moment it's a bit to do with cost and also the service and maintenance of it. Chris touched on it earlier. It's trying to make systems as simple as possible and putting appropriate systems in for the application that you're looking at. I'm sure that in the right environment for the right cost, there are systems that are more energy efficient that would prove to be better for different applications. But when you're rolling out supermarkets, you're doing multiple sites, you've got quite a transient workforce, all of those things taken into consideration, you have to put something in that you're going to be confident that people can deliver, competent people that can maintain and service, and that engineers are going to be safe working on. So I think there's certainly a place for Cascade, as there are with other refrigerant solutions out there. It just at the moment, transcritical CO2 fits very well into the retail environment.
Okay, thank you. Some comments and questions coming in from the training fraternity. Useful context coming in. For a start, training on flammables. This should all be part of the mandatory training under the Health and Safety at Work Act, and also again showing that everything is linked. The belief that there's little resistance to upskilling from the engineers, but actually at the moment the awarding bodies cannot keep up with industry. This is a real barrier. So it just shows that there's work to do on all fronts, I think, is where we're going on that. Now, we can't have a discussion like this without the question coming up, which I'm sure Chris would like to tackle, which is, can't we just carry on with the chemical refrigerants that everybody knows about? And it's that, is there room for both? Is it one or the other question?
Thanks, Andrew.
Hospital pass that one for you.
I think the answer is no. I think there's we can't carry on the way we are. The Kigali amendments to the Montreal Protocol that John mentioned earlier, we are now phasing out chemical refrigerants, albeit HFCs. I guess what you're referring to is HFOs and HF or the A2Ls, but you're still talking about an order of magnitude of a GWP that far exceeds a natural refrigerant. And to me, though they're not drop-in gases, which was I think a slight area of confusion when those products came to the market. You're having to replace a system. You're having to invest in a new system. Why would you invest in something that is potentially not future-proof for you? That's not a sound investment in any way. And no matter how you're spending your money or what you're spending your money on, you want your asset to last as long as possible. And again, when we're talking about resource use, we would want to make assets last longer. Cooling as a service is now a conversation about how do you look after assets in the built environment to elongate their life and keep them for much longer than we're used to. So I guess for me, and again, I'm biased, but that's my opinion. You asked for it, I think the answer is no.
Just to add to that, I think it's one of those questions, Andrew, that you get a very different answer if you were asking the question in different regions around the world. So,
yeah.
You know, I think with where we are in Europe at the moment, with the understanding of CO2 and the broader, you know, not just CO2, but natural refrigerants, I think we're in a pretty good place. I think we've got a workforce that are up to the challenge. I think if you look across the globe, the challenge in some regions from an environmental perspective, so the high ambience, it's going to be a different type of challenge. But there's also a challenge there from the skill-based point of view. But you know, personally, I look at the different solutions that are out there at the moment, and I find it quite difficult to really personally to justify to myself why I would look at a solution which wasn't a natural one. Although I do get that there are certain applications where a man-made refrigerant may still be more suitable, but I think that's going to be short-term.
One of the reasons we have events like this is to try and spread the word about all refrigerants, and I'm very delighted that we can keep talking about CO2. In a minute, we're going to have a quick discussion with two other gentlemen, which we'll be talking about an installation. But first, so this is the bit where I pause as I scan down the list of questions to see whether there's anything important that we've missed at this point. I guess I'm going to bring the panel back after the installation discussion because we'll have doubtless had some more questions in the meantime. But here's the one just to, I guess it's for you, Chris, really. So we've heard from John, this is a demonstration of an end user driving things in CO2. What about other end users? Is the message catching on about naturals, or does work still need to be done by the industry on the value?
And that's a good question. And maybe to be clear, I don't think we should downplay John's efforts in this field. John, I think, has been more than a pioneer. But I think the last time we looked out of the top 10 UK retailers, there's only one that does not have natural refrigerants as their current specification for new equipment. And yeah, I guess again, it's just that direction of travel that we can all see. North America's a bit further behind just because they haven't had the set of parameters that has encouraged us to innovate as a country and as a continent. You know, energy prices, F-gas regulations, etc. But yeah, things are changing. Again, the fact that the California Air Resources Board are now setting regulations that are stricter than the F-gas regulations. If you watch what happens, generally, that's where the ripple effect starts in the United States. And again, it's territories like that are going to move the needle on volume of equipment, bringing down the cost of equipment globally. There's places in Southeast Asia that are trying to leapfrog HFCs from HCFCs straight to naturals. So again, if you're looking at people, countries, nations like that are trying to become westernized at a great rate and investing a lot of money in their infrastructure, those are the choices they're making. And I think generally that is the direction of travel, and I think most retailers are realizing that, and I think obviously retail refrigeration is part of it. And I think, yeah, it's not without its challenges, as John's explained really well. It's about competence in the workforce, and again, getting a simple solution that can mean you can get that competence quicker and easier. But yeah, it's by no means a cut and dry thing yet.
Great, thanks. One of the beauties of virtual conferences is that we can run on a few minutes over. So if the panel is still able to, we'd like to bring you back after this short section. But for now, thank you very much. And we'll hand straight on to Indy and to Xavier, a contractor and Panasonic worker. In collaboration, they've worked on a very interesting installation. And I have a sheaf of papers here, which has got questions on it. So I'm hoping that you're very well briefed, gentlemen, and that it will just go like an ordinary conversation when I ask you the questions. And it's about the Tampopo project. So I think, Xavier, you're going to briefly say where you're coming from on this. And Tampopo They're a sushi supplier, are they not? So can you explain how you got involved with CO2, with Panasonic CO2, with a sushi supplier?
Hi, so good morning, everyone. Yes, so I was working with Tampopo, who is actually a sushi manufacturer, who is supplying much of a large supermarket in UK. There was already concern for the last few years about the environmental impact. So they were starting to use eco-friendly packaging. They was trying to use organic food. So it came across about them own developments of them manufacturing and them wish to develop into a greener solution. So the ideas came to combine also a little bit like the Biocop project in France with Panasonic. It's kind of a supermarket who would like to really show to the end user them full capacity or them desire to be green from the food they supply to the equipment they're using. So that was the main reason why CO2 was put on the table.
Okay, and so Indy, you're going to tell us about how that installation came about, what it comprises.
Well, hi everyone, my name is Indy. Just to introduce myself briefly, I've joined Panasonic 4.5 years ago as a technical support engineer, and part of my role within the technical department is to provide technical support on VRF and CO2 gas coolers. So
Okay.
at Tampopo we have 5 gas coolers serving 4 cold rooms. There are 3 chillers at 3 kilowatt cooling capacity each, and 1 freezer at 4.5 kilowatt cooling capacity, and working at minus 25 degrees room temperature, where we have two horsepower units serving that freezer cold room. That's just in a brief overview of the installation.
Okay, so this one goes back to Xavier. So why CO2 then? Why is CO2 so important for this installation?
CO2 was important, I guess, for my customer, but also for me as a company. As I mentioned before, my customer was really trying to improve them image of providing organic food and CO2 solution, greener solution. But also for me, it was quite interesting because I know that large supermarket like Marks & Spencer are using CO2 for already quite a long time. And as a company, we can't be on a smaller scales doing small corner shop. We were still using 4.4, 4.52, or even now A2L, but we really wanted to keep training our staff to future to the technology who will come across quite popular in a few years time. So I wanted to get my staff trained and getting knowledge for my own company to get ready to provide a good servicing. So it was a combination of my customer view and my view too.
Okay. So what are we talking about in specifics then, Indy, in terms of gas charge, the equipment, the evaporators, the cooler? I'm asking 3 questions in one, and you'll have gathered that. So tell us about...
Yeah, as mentioned before, we have 4 systems on site at Tampopo, and on average, the system will charge around 2.2 kilogram. Mm-hmm. And the pipe run was around 10 meters. Please be advised that the 2 horsepower maximum pipe run is 30 meters, and on the 10 horsepower, it can go up to 100 meters. The gas cooler is built in with a system charge check, which is called adjustment during operation. So it's simply a comparison check against the system on and off value. So based on the ambient temperature, during the operation, the system pressure will depend on the ambient temperature. So therefore, once we know the ambient temperature, we can compare the working pressure against the table provided in the manual.
What about things like the expansion valves? Are there any particular considerations there, or indeed the control system?
Yeah, for the expansion valve, our default is Corel. Mm-hmm. And but other brand like Sagonemia and Danfoss AKV can also be used. At Tampopo, we use E2Vs. The Corel is pretty much plug and play. For the RDM, few settings are required that can be obtained from either from Panasonic US or RDM. Oh, sorry, I forgot to mention that on at Tampa, we've got two type of controllers. We have the Corel and we have the RDM as well.
Yes.
Okay. Yes, please.
Yes. Just to adding some information, for me, it was one of the first projects we did have as a manufacturer. So we choose Panasonic on the outdoor unit, but we choose the Danfoss controllers provided by Panasonic. We use the Danfoss controllers on its own, and we use third. So we have 3 different controllers to build our more knowledge and to also to choose in the future which product will be more reliable for the future. So it was kind of a test also on the controllers.
Yeah, adding to that, the Corel and RDM controllers were chosen because they are known for their reliability in the refrigeration industry, especially in the UK. And we have around 600 plus gas coolers installed all over Europe on different type of controllers like Danfoss, Eliwell, Dixell, Bego, AKO, Worm, and so on. There are 2 ways that the Panasonic gas cooler can operate. So the first one is the demand control, which is a run signal from the cabinet control thermostat, or the second one is a pump down mode, which is basically a run signal from the system pressure. So when the cabinet set point has been achieved, the expansion valve will close, and obviously the pressure will drop and the system will switch off accordingly. And is the opposite. So when there's a call for cooling, the pressure will rise and the system will start again. I mentioned earlier about the on and off value, so that can be changed. So you can change the actual when you would like the system to start running and when you would like the system to switch off.
So overall, I guess this is a question for Xavier. Overall, it all went smoothly. You were happy. The client was happy, because it's very pioneering for a relatively small client, a small end user to opt for this.
I would lie to say it went very smoothly, not because the technology, not because the Panasonic was quite reliable, but it was a learning curve for us as engineers and for all our staff. So with the support from Indy, we did take the opportunity to train and to train ourselves with a product, with a live situation. I think so that was the best way, because we all went to different trainings. But what you are learning on an A4 paper or through a computers will never be good as a real installation. So that was, yes, at the end, customer is satisfied. We start by 1 unit. As you know now, we are starting the 5th. The customer is already pre-ordering 2 more. So that's for me, is with this project we carry on for 2 years time, we're increasing, the customer satisfaction is here. So that's for me is, I will say, was approved, and yes, the project went well based on these points.
Excellent, and I think you should be applauded for pushing from your side the CO2 experience, because as we've discussed, the skill base at the moment in the UK is there aren't so many trained CO2 engineers, and that means that there aren't so many customers yet who know about the opportunities. So thank you, gentlemen, and we're going to call some more of the panel back, because we have, now what I've been trying to do, hopefully nobody noticed behind the curtain, looking at my clock, looking at the number of questions that are coming in, and trying to keep all the balls in the air. But as promised, I'm going to bring the panelists back. So Chris, John, Joma, do you want to bring your screens back on, and we'll crack through a few more questions, because we can't make the invitation to our audience to ask questions without trying to get through a few more of them. Chris has just disappeared, which has disturbed me a lot. Oh, he's back. So here's a good one I'm going to throw this one at John, I think. What do you think, actually I can't throw it at John, I've got to throw it at Chris really, when you'll hear why in a minute. What do you think the weak link at the moment in take-up of CO2 is? Is it the end user, is it the installer, or is it somewhere else in the industry? You'll see why I couldn't ask you, John, because it's an obvious answer. Not you. Chris.
Yeah, thanks again, Andrew. That's a good question, and a difficult one. And I think the honest answer is it's a bit of everything. The choices of refrigerants now, we're looking at having to reduce GWP globally, is that we now are left with choices of refrigerant types, which is one of three things: either flammable, toxic, or high pressure. So again, it comes back to people understanding those choices, understanding what's fit for purpose in their application, and making sure that the training's there and available, and etc. There's an idea of CO2 is high cost. I think that's no longer the case. And again, I think it's a bit of chicken and egg, but the more it's adopted, the lower the cost goes down. It's like any technology, the more it's used, the cost is lowered as well. And obviously we're comparing the cost increase of CO2 to current methods, so HFCs, as an effect. HFCs are now a flawed benchmark because they are being phased out globally in line with the Kigali Amendment to the Montreal Protocol. So it's just that things take time to change. Change management is obviously on a global scale in a technology in a sector like this is a very difficult task, hence conversations like this. So yeah, I know that I've not specifically answered your question, but it's a little bit of everything.
Okay, great. Yeah. So Xavier, perhaps you've got a take on it. Have you been talking to other customers? Has there been a bit of an interest based on this experience?
Yes, I will say that Tampopo was a project we started 2 years ago when we start slowly by slowly, but we know this customer quite closely, and we use this customer to get confidence in ourselves to be able to approach larger American chains, who is actually our customer base, but it's difficult to approach larger customers with a week of confidence. So now, yes, we are already starting 2 projects with major players in the food industries, where they can feel more confidence between Tampopo project was up and running for the last 2 years, and for also ourselves, who can be more confidence to be nationwide providing servicing on CO2. Yeah,
that's good news. I guess one of the potential barriers to take up is this perception of cost of components. John, I know in the past you've been quite vocal about supply chain costs. What's your current view on supply chain?
My current view from a cost perspective is that there are certainly more challenges in getting a cost-effective solution in smaller installations. So in the estate that I looked after previously, when we had large 60, 70,000 square foot supermarkets down to 2,000 square foot convenience stores, trying to make the model work in a convenience store was more difficult because it was just trying to get the cost into the right place was just far harder to do. But we've had to make some compromises along the way. There is definitely still a cost challenge there, but certainly as more components become available, as more manufacturers move into the marketplace, we are still starting to see a shift. As Chris says, this is, the move to naturals is becoming very much the norm going forward, and you've just got to look at the bold commitments that large companies are making now around becoming carbon neutral, the challenge that the government's thrown out, and I think it's going to have to form part of that going forward. So there is a bit around, if you're doing a one-off installation as a owner occupier, I can imagine it would be still a challenge from a cost point of view. When you're looking at multiple sites and larger rollouts, there is the economy of scale. But I think if potentially all you're doing by saving money now is being in a place where in the future you're going to have to spend more money because at some point you're going to have to take a different approach to the refrigerant in your estate. So I think overall, certainly from the large retailers that I've worked with and all the ones I know, as Chris said, I think there's only one now that hasn't got natural refrigerants as their refrigerant of choice. So it's being done for the right reasons.
And I think it always is the way, isn't it, that the supermarkets, because of volume, because of just the scale of the estate, drives trends, and so we see it, as you say, supermarket cooling has embraced CO2 in a very big way. I guess the question that is out there is how do you move this to it's the question that comes up all the time. How do you move this to the next layer down? And I guess it is about education. It's about talking to people. Xavier's proved with smaller retail customers. But we have a question here that says, aren't larger installations still a cost problem? So they're thinking about distribution centres and larger cold rooms, or are we starting to address that as well? I don't know whether Chris or John wants to.
Well, I was actually say I don't know whether John's best answering that. John obviously has a lot of experience in distribution centres for retail, as well as the stores that John would have in his estate, M&S and at Sainsbury's before. But no, I mean, we're seeing CO2 systems being put into large areas as well. I mean, the alternative's normally ammonia, but no, I guess in short, our experience is CO2 is being used at that scale and fairly competitively. I don't know whether, John, you've got some more insight.
Yeah, I mean, for me, natural refrigerants in distribution have been the norm for a considerable amount of time. There's a few different flavours creeping in now, and there's a huge amount of work that's being done to make sure that distribution centres can be as energy as efficient as possible, and CHP absorption systems, ammonia, CO2, they're all playing a part in it, and I think it's I can't remember the last distribution centre that I heard about or that was being discussed that was using a man-made refrigerant. I think they're all moved over to naturals. I think it's quite a common thing. I think if you look at larger supermarket installations, yes, there's a compromise. If you look at the estates out there and the number of packs that are going into supermarkets, there are far fewer packs going into a supermarket installation, and that was one of the ways of trying to drive down the cost. So, is it a direct comparison between a HFC solution from a cost point of view and a natural? No, there's lots of work that has been done to drive down costs, and some of that has meant that there's a few compromises has been made. But things are starting to change on that front. I mean, one of the comments. I mean, it's very nice to say that supermarkets have been driving this agenda. I think we drive some of it, but we only do what the experts out there are telling us to do. Jokingly, I said I'm a shopkeeper, but I'm not far from it. I've not really had a spanner in my hand for a long time, and I've never designed anything. I'm relying on the industry to come to me to tell me what I should be doing. All I really do is share with them the challenges that I've got internally and the pressures I've got upon me to try and drive down the carbon footprint. But the industry, the first thing that happened when I walked through the door 13 and a half years ago at Sainsbury's was that people were doorstepping me saying, why aren't you doing CO2? Why aren't you moving to natural refrigerants? So the industry's got to take the credit for it. We just helped sort of knock these things along. But I think you're right, Andrew. It's about education. It's about us understanding the broader commitments. And in some instances, it's about us educating our customers. I think that, fortunately, we're probably by the pressure that we have put upon us by NGOs and governments, we're probably quite enlightened to what we should be doing as an end user. I'm not too sure whether some of the refrigeration industry's clients are so well informed. I'm not trying to be disingenuous there, but part of it is down to us as a refrigeration industry to be advising end users what they should be doing and how they should be spending their money wisely. And I think we all agree that there are occasions where you've got to spend that little bit more to get more out of your system, whether that's to make it more energy efficient, make it more reliable, or whatever. So it's a large part of it does come down to education.
Great. Thanks, John, for that. That's you're being too modest, but we'll let it pass. the clock is ticking. We have 3 or 4 minutes left, and I'm going to give you a couple of comments that have come in on the wires, and then I'm going to ask one specific question, and then we'll do my classic wrap up, which you gentlemen can think about. What one thing should we be telling the industry now about CO2? So that's for you to think about while I say this one thing, which is one of our questioners has said, the drive from Kigali is going to be towards efficiency and lowering carbon. So do you want the stick or the carrot? Because that's the way things are moving, which I sort of agree with. Question about, we've talked about refrigeration a lot, which is where most of the CO2 has been going. Is there a world coming, CO2 air conditioning? Is there a world coming for CO2 heat pumps? Anybody want to answer that? Perhaps Joma wants to come back. Is he still there? Joma, you still there? CO2 for heat pumps. There's, you know, from my point of view, I'm thinking there's probably another question time there.
Yes, I think. Sorry.
No, carry on.
Yes, I think the CO2 for heat pumps is in Japan we call this EcoCut equipment. This developed since years ago, and is working super fine in Japan. But honestly, in Europe is still not introduced yet. But we already know that the CO2 heat pumps are working in Europe too. So in the future, probably we hope that the CO2 also is be working in heat pumps. That's true. I think they have a great future.
Excellent, thank you.
I would like to say we still have some few Sanyo CO2 heat pump still working.
Indeed, yes. The Sanyo heat pump.
Yeah, they're still working.
Many viewers will know about that. Or perhaps we'll see the rebirth of the CO2 heat pump in the future. But as I say, we're talking about cooling today. It's World Refrigeration Day. So it's time to wrap up. And we tend to wrap up with a very quick one sentence. What one thing would you say to the industry? So if, now I know the independent gentlemen will be briefed for this, because they know that I do this, but the Panasonic gentlemen, you might find it a surprise. But is there one sentence that you would give to the watchers? I'll start with Indy.
Stick with CO2. CO2 is green, and the way. Sorry, did you say one sentence?
Oh, 2 sentences.
Yeah, stick with CO2, and CO2 is green, is the future.
Brilliant. Joma?
CO2 is the future.
You can't have the same sentence. That's not allowed. Okay, we'll stick with that. That's a consensus, isn't it?
Okay.
Okay, Xavier, do you have a sentence for your fellow contractors out there? You're on mute, unfortunately, Xavier, so you're going to have to click your mute off.
If you want to learn something as an installer by moving to A2L or other refrigerant, why not moving to CO2, learning something, and that will offer you a very long-term solution. Just to adding regarding cost, you was asking John regarding cost on the CO2. For me, costs being reduced, because don't forget on the machine we are dealing with. Small restaurant like Subway, McDonald's, Domino's Pizza, up to small distributors. And for us as a company, we're only going to use 1 or 2 machines. The machine we are doing for Tampopo was able to switch over from chillers to freezer with the same machine, with the same expansion valve, the same controllers. So regarding the cost of a stock, as for an installers and for the knowledge of your engineers, that's really shrink a lot, and there's a huge benefit from that. And that's only available on the CO2. You can't apply that to any other refrigerant.
Thank you, Xavier. Very good. Chris?
You actually caught me off guard as well, Andrew, but I'd probably say 2 very quick things. I guess if we all look back at history, we all know what was said and how it's remembered when CFCs were phased out. And I think we need to look at alternatives, because the same is about to happen with HFCs. And we want to be remembered, or if you do want to be remembered for doing the right thing, then pay attention. And I think repeating what I said earlier, pay attention to what science tells us about threats from nature. And yeah, naturals don't deplete the ozone layer. They make negligible zero contribution to global warming, and they're sustainable and energy efficient solutions. And if adopted now, they're future proof.
Thanks, Chris. And John?
My bit would be, as an industry, keep informed and understand your customers' needs, keep investing in your training, and keep doing a great job. We've got a great industry, we're doing some great things. It's great to celebrate it today as part of World Refrigeration Day. But we're in an industry that we should be very proud of, and there's a lot we can do to have a significant impact on global warming and environmental issues, and keep putting the effort and working hard to do that.
Thanks, John. So it remains for me to thank everybody. So thanks, panelists. It's been a really interesting conversation. Thanks to Panasonic for supporting this event. Without the support of sponsors, we can't do these events, which is where the advert comes in. If we want to talk more about these, then do feel free to come and talk to us. We can, within reason, have as many discussions as people will support. Alfredo, so you're going to add a little word in it now before I do my final wrap up, then I'll see you joining us.
Yeah, first of all, Andrew, thank you very much for this event, and I think we paid a very good tribute to the World Refrigeration Day, presenting CO2 technology. If I could also use just one phrase, that would be embrace new technologies. And again, thank you for all the panelists who participated to this event, and all the persons that took the time to join us and follow our information.
Thanks, Alfredos. So from me, just to prove that we are refrigerant agnostic, we do have another question time coming up, which is on A2Ls for cold rooms. It's on Thursday, the 9th of July, and it's featuring one Brian Churchyard amongst other panelists. We like to put our end users out there in the firing line to draw you in. But thanks very much. The one thing, of course, that I'm always being reminded of, the beauty of the virtual question time is that they are recorded, and the recording will be available shortly. We edit down the bits where my phone rings in the background and that kind of thing. Luckily, I had it muted today. Thanks very much. Enjoy the rest of World Refrigeration Day. Do watch out for the tweets and the LinkedIns and all the good stuff that's going on. And it's a great industry. It's a great time to celebrate. And I think we proved today that connecting the cold chain is a great thing. So thanks very much for listening, and goodbye to you all.
Thank you. Thank you.
Thank you very much.